Welcome back. We solve for the value of k given this math problem. For those who have not subscribed, kindly consider to subscribe, my good people. Now let's dive into this providing the solution to this problem. We have k minus 4 raised to power 4 is equal to k raised to power 4. So what is the value of k? Solution. We have k minus 4 raised to power 4. This is equal to k raised to power 4. Okay, so we can write this equation as k raised to power 4 minus k minus 4 raised to power 4. This is equal to 0. Okay, again we can write this as k squared multiplied by 2 minus k minus 4 squared, everything squared. This is equal to 0. Remember, we are applying the indices identity, that's a raised to power n multiplying by m. This can be the same as expressed as n multiplying by m. Okay, so that we are going to have, now this is the difference of two squares expressed as a squared minus b squared. This is equal to a minus b, a plus b. Okay, so that we are going to have our a in this case is equal to k squared and our b is equal to k minus 4 squared. That's our b. Okay, so that now we will have k squared, okay, minus k minus 4 squared. That is the first part, and then we'll have k squared minus k minus into bracket k minus 4 squared. This is plus, sorry, squared. Okay, so we can call this again, we can call this one case 1 and this case 2. Okay, so for case 1 we have k squared minus k minus 4 squared is equal to 0. So now we'll have k squared minus, now this is k minus 4 squared, applying the algebraic property that states that a minus b squared, this is equal to a squared minus ab plus b squared. Okay, so applying this property, we are going to have k squared minus, this is 8k plus 16, this is equal to 0. Okay, so we're going to have k squared, we open the parentheses so that we'll have k squared negative times positive, you're going to have plus 8k, negative times positive 16, you have negative 16. This is equal to 0. Okay, so that we're going to have k minus k squared. This will simplify so that we'll have 8k minus 16. This is equal to 0. So that we'll have 8k, you take negative 16 the other side, on the right hand side, so that we're going to have the value of k as k equal to 2. Okay, so that's the first value of k. And let's solve for case 2. Let's solve case 2. For case 2 we have k squared plus k minus 4 raised to power 2. This is equal to 0. Okay, again we'll have k squared plus into the parentheses, this is k minus 4 squared. Now applying the algebraic property that states that, now this case we have a minus b squared is equal to a squared minus ab plus b squared. So applying the property, we're going to have k squared minus 8k plus 16, this is equal to 0. Okay, now we have k squared plus k squared positive times negative, that is minus 8k, and then plus 16, this is equal to 0. Okay, so that we'll have k squared plus k squared, this is 2k squared minus 8k plus 16, this is equal to 0. Okay, now we can divide everything by 2, so that we're going to have k squared minus 4k plus 8, this is equal to 0. Okay, now to solve for the value of k, we introduce the quadratic formula which states that minus b plus or minus the square root of b squared minus 4ac over 2a. Okay, from our quadratic equation, we have our a equal to 1, our b equal to -4, and our c constant is equal to 8. Okay, so we just substitute to our equation so that we're going to have -4 plus or minus b squared is -4 squared minus 4 times 1 times 8, divide everything by 2. Okay, this is 2 times 1, so that we're going to have 16. That is negative times negative, this is 4, plus or minus the square root of -4 squared is 16, minus 32, divide everything by 2, so that we are going to have 4 plus or minus, this is 16 minus 32, which is equal to -16, divide by 2, so that we are going to have 4 plus or minus the square root of 16. You can express this as 16 multiplied by -1, divide everything by 2, so that we'll have 4 plus or minus, now the square root of 16 is 4, and the square root of -1 is I, divide by 2, so that we're going to have 2 plus or minus 2i. Okay, so now we'll have k1 is equal to 2 plus 2i, k2 is equal to 2 minus 2i. So that gives, this means that we have 2 complex roots. These are 2 complex roots. Okay, so our solution has got, we have 3 solutions. We have the first k, which is equal to 2, or first k is equal to 2, which is the only real root we have. The other k1 and k2, these are complex roots. And this is the solution to our math problem. Thank you for watching, and kindly remember to subscribe.